Okay, so far we have already discussed about the basics of this array. Now, yes, we were about to discuss this take two arrays and perform addition of corresponding elements of the array. I gave this program as a uh, homework, so I hope you might have done this. If not, no worries. I'll be telling you this. So for this, what we are going to do is we'll take two arrays and we'll perform the addition of each element in the array. Okay. So not addition. Basically, we are going to perform the extend operation with this. Okay. So let's see what we are doing. ARR1 is equal to an dot array. This is the standard, and I am taking I integer, comma, or and here we are taking 2 comma 3 comma 4 comma 5, and then arr2 I am taking this is an dot array, and I am taking again this this is integer array, and here I am giving 6 7 8. Okay. Now what I am doing is what I'm going to do is um final list we are going to uh, so what I am trying to do is I am trying to extend this array 1 with array 2. So um, how we can do that? So basically to do that, what we have to do is arr1 dot extend and extend sorry extend ARR2. We can do it like this, and then we can print ARR1. So this is print. Okay, so first of all, I have to execute this. Okay, now this will get executed. So you can see here this array is extended. Now, again, the next task what we are going to do is let's say I have array like this, and what I'm going to do is if I do ARR1 plus ARR2. Okay, ARR2, and this we are going to store in ARR3. Okay, and then if I print ARR3, ARR3, I do. So in this also you can see the when I'm printing this ARR3, it is extending the this array. Extending means after this it is adding this array. Okay, but ideally, what I want is that two and six should be added to and create eight. Then 3 plus 7 should be 10. 4 plus 8 should be 12, and 5 plus 9 should be 14. Like this, it should come over here. Okay, that's what we want, but it is not looking possible over here. So what I am going to do is I'll just convert this. Okay, so how we can convert this? So ARR1 underscore list is equal to a list ARR1 dot to list. Okay, and then ARR2 underscore list is equal to ARR2 dot to list. Okay, now final list is equal to ARR1 underscore list plus ARR2 underscore list print final list. Okay, okay. So this is what we have done. So now you can see here when there is a lot of background noises there at my place. So Okay, no issues. Okay, am I audible?
Yeah, yes, sir.
Sorry, sorry for the disturbance. Okay, so now what? So, what we have, what I want to do is that we need to take two arrays and we have to perform the addition of corresponding elements. So, but in both way, we have seen that if I am doing like this or if I am doing like this, in both case, what it is doing is it is just concatenating. This is concatenating the each elements of the array. So, then for this, what we have to do is we have to apply the looping concept over here. Okay, so with loop we will add the numbers. Okay, so how we can add the numbers using loop. So let's see how we can do that. And this thing can be applied both in in list also, and the same thing, same type of code can be applied even under the um, array also. So let's see how we can do. So let's see here. So how we'll do for I in ARR 1 comma ARR 2. Like this we can do. Okay. So this you can do in NumPy array also. We have done this in NumPy array. But here also you can do. So for NumPy array, what you can do is simply uh, you can convert these things into the array. So this is like ARR1 uh, mm, dot NP is equal to N here. Uh, so first of all, import NumPy as NP, and here what we can do is ARR1 dot NP is equal to NP dot array, and here I have given ARR1. Okay, then ARR2 underscore NP is equal to NP dot array, and here I have done ARR2. Now you can do this NP ARR final is equal to ARR1 underscore NP plus ARR2 underscore NP. This can be done, and then you can just print the final array, print ARR underscore final. Okay, so you can see here all the elements are added together. Understood? I will take ARR1 comma ARR2 comma print ARR final. So you can see this is ARR1.
We can do this using loop as well, right? For loop as
For loop as well. Okay, no, this is very easily you can do.
mm-hmm.
So,
On the length, yeah, we
do
can
you
put a
want to try
condition.
or do you want to try or should I tell you?
You can do actually. I'm just joined through the mobile, so you can do.
Okay. Okay, so let's see how you can do using loop is like for I in, or you can take any element for elements in uh, like you can do for in range length of let's say ARR 1. Okay, so by this you will be able to get the length. Now what you can do is uh, I'll take a blank array over here. So here result is equal to np dot array. You can do, or you can make a blank list also like this. You can take just blank list over here. I have taken blank list and a result is equal to, and this is ARR one underscore list. So you can say ARR one underscore list of I, then plus ARR two underscore list of I. You can do like this, and then you can print a result array. Okay, so you can see, oh sorry, elements under I, elements. Okay, and now you can execute this. So it has added all the elements together. Uh, no, it has added 549. Oh, sorry. Result dot print. Then here I have to use this. Okay, so this is the final result array. You are getting this. Okay, is this clear to everyone?
Yes, sir.
See, all these things will be possible when you will do your own practice. So you can see I have added the array in two different ways. So this is using the
This,
NumPy array also.
yeah, actually,
Yes,
this is like for each, right? Means it is traversing each element, and
yes.
and it is joining means from it is just one question. For example, if there is a scenario that the length of the arrays are different, like four arrays in the first one, and the size is like it is third array, array size in the second one. So still this approach will work, right? It's not that it will be only for
No, then this approach will not work. This
okay.
approach will not work. Yeah,
Mhm.
even in this in NP case also, because it will be searching for the corresponding element. If corresponding element is not there, how it can print that?
Mhm.
Okay, so adding is only possible. These arithmetic operations are only possible when you have the similar length. Okay,
Okay.
so like if I have if it is not there, then let's see what happens. In a NumPy array, you see it is giving you error operands could not be broadcasted together because there are four element in one array and there is three element in another array. So for the fourth element in the first array, it is not getting any corresponding element in the second array. It is not getting any corresponding element this for five. Understood?
Got it. Yeah, yeah.
So at any point of time, if you are doing this, you will not get the desired result. Here in case of looping, also you see it is telling you list index out of range because means ways are different, but output will not be generated because at any point of time, it will be might be searching for the corresponding element. The
Okay.
number of element needs to be same. Okay.
Okay. And if it's not the same, then we need to like append one, means in one more element like zero into the another one and try to and do this functionality, or there is another approach as well.
Yes, that approach you need, you can follow, but for that again, the you need to follow the lot of conceptual part in that. Okay.
Okay, got it. Yeah.
Okay, so you can make a check out of it, but that is not a practical thing because anyway, it would require for your better understanding of the concept. Okay, okay, so let's convert it back to four element, and you can see uh, it is working, and this is, oh no, this has to be executed first, and then yeah, this is working now. Okay. So like this, you can do these operations. Okay. Now let's start with some array concept part. So now we are going to start with the one one small algorithm. So we'll see how we can do these an algorithm implementation. So in overall DSA, from today, algorithms are going to get started. And in overall DSA, we'll try to study 2025 algorithms and will implement those algorithms as searching operations. So there are two kind of search, three. Okay, so in H4, there are two kind of searching operations are there. One is linear search, and then another is binary search. Okay, so when I talk about the linear search, what happens is linear search is responsible for to search the element one by one at each point. Okay, so let's see how this linear search works. I'll create an algorithm in front of you, and you can see how this will work. Okay, so first of all, we'll see linear search. So linear search is like going through with every element one by one, and once found, it returns the location. Okay, so basically what we are doing is the given element to be compared with each element index by index, one by one, or index will check. Once it is found, return the index value. Okay, so this is the thing that we are going to apply in linear search. So for example, now just let me explain by the example so that you can understand, then we'll implement that algorithm as well. So here, let's say I have 4, 6, 3, 3, 89, 56, 32, 50, 58, and then 33, and 70. Let's say we have these many elements are there. Okay, now someone says that I have to search 70. Okay, when I have to search 70, what I'll do is I'll just compare this 70 one by one in this array from starting. So I'll compare with this, then I'll compare with this, I'll compare with this, I'll compare with this. Till here I'll go and I'll search that I'll found that I have found this element at this index. So this index is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this index is 8. Okay, so it will return me the value 8 over here. Okay, that it will show that it is existing inside this. Okay, so uh, let's make this program. So import array as an. Okay, linear array. I'm just taking this array name as over here, an dot array, and I'm giving I comma, let's say I am giving this 4 comma 56, 89, 43, 67, 55, 90, 21, 45. Okay, I am giving this. Okay, so this array is created. Now, so now I'll write the linear search algorithm. Linear search. Okay, so I'll take I is equal to 0 and flag is equal to 0. Okay, so as you know, I'll be using while function I less than and till where this tool will work. So I want inputs from all of you so that you also can run your mind and practice this programming. Okay, so what I'm doing is I am taking this search element. Suppose I see as search element, and this element is, let's say, 67. Okay, so I have to search this 67 inside this array. Now, please tell me your one from inputs from you three, all from all of you. See, if I'll be only implementing, then I'll only learn. If you are not implementing and if you are not giving your thoughts as an input, you will not learn anything.
Excellent.
Don't worry if even if you are wrong. Please.
Yeah, in the linear search we can do is like we have to search the element 67, right? So sequential we can move like I
Shamila.
I
Yes.
less than the it should be the length
Mhm.
So length of
mm,
array.
yeah, length of that particular array.
Okay. Okay, I
And
have taken then.
yeah, and we will keep a flag. If we get 67 anywhere, we can just break that loop from somewhere. And sequentially, we will move one by one to search each element. And if we get the 67, we'll break from there and we'll check the index out from the.
Yes, yes, I understood. Good. I was expecting this answer only. So now this loop will start from 0. Now what we'll do is we'll take if no, we'll put a condition if search underscore element is equal to linear array of I. Okay, so this is the condition. If it gets, then what we have to do is flag is equal to 1, and we have to break it over here, and then uh, otherwise keep on proceeding with this. So I plus is equal to 1. Okay, so what we are doing is initially we are initializing this flag as 0, and then we are comparing this search element one by one with each. So this loop will start from 0, and it will go till the length of this array. Okay, and each element will be compared with this given element, this search element. So search element will be compared with this, with this, with this, with this, and as soon it will found, it will return flag is equal to 0. And on the exit of this loop, we'll check whether this flag is 0 or not. So if flag is equal to 0, then it will return that it will print if it will print that the given
Element is not
element
in the
does not exist. Okay, otherwise else if it is 1, then it will print element exist at index, and here will print at index and will print I plus 1. Okay, understood. So here I'll exist, I'll print this. Okay, so this, yeah, this part is, I'll make this comment. Okay, then mm, mm, mm. Why it is giving this error? Linear array in dot array.
length is it will take
No,
the
no, no.
start.
This is bracket mistake. This is bracket mistake. This should be bracket over here. This should be parenthesis, not the brackets. Now it will work. Okay, so you can see here it is giving you that element exists at index 5. Okay, so I'll just do like element here, and I'll make it more interactive. So then for dot format, you can use it like
So one more bracket at the end.
yes, one more bracket. Thanks. Okay, so it is telling element 67 exists at index 5. Okay, understood this very simple algorithm? You understand this?
Yeah, yeah.
Okay, so this is very simple algorithm of searching algorithm. This is general searching algorithm, which everyone generally performs. And what you can do, you can even this this is a statement as well. Enter the element to be searched. Like this also you can make it interactive. So let's say if I say 55, and it is telling me that 55 is at index 6. Okay, so like this you can do, and if I'm giving any element which does not exist, so it is telling me that given element does not exist. Okay, so simply you can do this operation. But The issue with this kind of searching algorithm is that, let's suppose there is there are around 1,000 elements are there. Okay, so element can exist at fifth position also, and element can exist at 999th position also. Means element can exist at starting or even at ending also. So when element is existing at suppose starting, like let's say fifth position, so it has to compare only four elements, and if element exists at just last, so before reaching that element, it needs to do comparison for 999 values, right? So it will take huge amount of time in those comparisons. So the time execution is not definite in case of linear search, right? When you perform the linear search, the time execution is not definite because it depends purely on luck that where that element exists. Okay, understanding the issue? Need to perform 1,000 um, comparisons from starting of array to the last of array, right? Understood? Yes, no.
Sir, can you repeat this one?
So, what I am telling is, suppose let's say I have a array like this. Okay. So, in this, suppose I have to search 70. Okay. So to search 70, I have to compare the comparisons till where this 70 exists. So 70 is existing at second last position. So suppose 10 elements are there in this array. So to and 70 is at ninth position. So to reach 70, I have to to do nine comparisons. Okay. If suppose I am searching 3, so to search 3, I have to compare these first, second, and third, three comparisons. So wherever the element exists, so let's suppose I have an array of size 1,000 elements. Okay, and if suppose element exists at the x most last at 1,000th position, so to reach at that element, you have to perform 1,000 comparisons.
Uh,
Understood?
yeah, yes.
So if element is existing at the beginning, you need to perform very less comparisons. If element exists at last, you need to perform many comparisons. So the it is purely dependent on the luck that where that element exists. So the execution time of this algorithm is not definite. It cannot be decided because of the uncertainty of the search element. Understood? Yes, no?
Yeah, yes.
Oh, yes, please. Priyanka, do you want to ask something?
No, no, sir. Okay, fine.
Okay, so just if you are not able to understand it still, just imagine in a way, like if you
Sorry to
are
interrupt you, 1 second. Yeah, this meeting is will end at after 1 minute. 1 minute left in the meeting. I'm just asking. Not sure.
no, it will continue. Don't worry.
Okay.
Okay, so let me put you in this way, like if let's suppose you have you go to a mall. Okay, or you go to a shopping store. Okay, now in shopping store, you do not know that how things are arranged over there. You don't know which rack is at which place. So what you have to do is you have to go through one by one at each kind of each section, and you need to find that which rack exists at which place. Okay, So maybe the item you might be looking for in the shopping mall might be existing at the rack on the second, third position itself. Or let's say there are 100 racks are there, so that the element may exist at 99th rack also. Okay, so existence of rack which you are searching is purely dependent on your luck, and it will take the time cannot be decided that how much time you will take to get that element because of unknowingness of that position. Okay, okay.
Yeah, yeah. Yes, sir. Yeah.
Okay, so because of this, the time complexity of this linear search was very unexpected and it cannot be decided, time complexity, right? So because of that, one another concept got introduced, that is binary search. So what is binary search now? So in binary search, what we do is we try to arrange the elements in sorting order. First of all, when you are doing the binary search, the basic requirement is elements should be in sorted order, right? Elements should be in sorted order. So when elements are in sorted order, so now how binary search will be performed? So now let's say we have this array like hash, and I'm taking elements like I'm taking now elements in the sorted order. So I'm taking um let's say 11, 15, then 21, then 25, and then I'm taking 35, then 47, and then I'm taking 53 and 59, and then 66 and 72. Like this, I have element now. Okay. So now this is in sorted order now. Now what I'll do is I'll just compare the elements. So let's say I have to search here 66. Yeah, yes, I have to search 66 over here. Okay, so how now searching will be performed? So first of all, it will see how many elements are there. So what is the initial index and what is the biggest index? So this is the initial index and this is the biggest index. With these two indexes, it will try to find which is the middle position, right? So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements are there. So the middle position will be fifth. So fifth index. So element at fifth index will be this. Okay, it will directly reach on this position and it will compare this middle position element with this. Okay, now what will happen? Now it saw that now 66 is bigger than this 47. Okay, so now what it will do is it will leave the this entire part. This entire part is now automatically skipped. Now since this array is in sorted order, so now it with this comparison, it is clear that 66 cannot be there before this in this array. Okay. Now the existence possibility of this 66 is just this, not more than this. Understood? Any doubt so far? Doubt so
What
far?
if in the case of it is not sorted? Not sorted.
Sorry.
What if it is in the case of not sorted? If the list is not sorted.
If if it is not sorted, you first of all you have to sort this list.
Hmm. Okay.
Okay, so the basic requirement with the binary search is that elements should be in sorted order. So if it is not sorted, first of all, you have to sort the list.
All right.
So we'll sort the list first of all. So now you can see here, these elements are here. Okay, now I know that element cannot exist at this area. Now what we'll do is we'll perform our searching with these elements only. So now this is the biggest position and this is the smallest position. With these two smallest position, we'll find the middle position. So middle position will come over here. Okay. Now it will this will be compared with this. Now these two will become and these two are getting compared. When these two are getting compared, you can see here now again this 66 is bigger. So now it know that it will not exist at this area even. Now you have only these two elements to search, right? So it will keep on searching like this till it is sure that we have reached that element that we want, or now there is no possibility. So now let's see if the element is 68. Okay, so like searching like this, it will reach till this place only, right? And here it will try to search, and once it will see that now there is no element, so it will say just that no such element exists. So when the high position will be less than the low position, then it will say that. This element does not exist. Okay, so we'll implement this slowly so that you can understand. Understood the logic how this binary search is working? Did you understand the logic how this is working? All of you, Arvind, Priyanka, and Shamila?
Yes, yes,
Okay. Okay, so I'll create a function for this. So let's see, I am defining a binary search. We search. And here I am doing what I need is one is array, one thing is array, and another one is the value that I want to search. Search value. These two things I want. Okay. So at initial, this left will be started at the starting index, and the right position will be at the length of this array. Okay, so left is equal to 0 at a starting, and right is equal to the length of array and minus 1, right? Why minus 1? Why minus 1?
So that
In
the length we are starting from zero, right? So left is zero, and it should take total of length
reverse
minus
on
one. Mm, because the length will be total will be like at initial index starting from zero. Therefore, that is the reason.
So if there are 10 elements, let's suppose if there are 10 elements in the array, the biggest index will be 9. Okay,
Yeah,
because the index value is starting from 0.
zero.
Okay, so that's why we are taking length array minus 1. Now, while left is less than right. Hmm, okay, so this is the first thing. This is the termination condition. So we'll keep on checking these elements till this left value is less than right. Okay. So we have to find the mid value. Mid value is equal to left plus right divided by 2. Not divided by 2, we'll say remainder. Okay. So now if ARR of mid is less than well, first of all, we'll take with the search equal to. So if it is equal to the search value, SEARCH search well, then it will return that it has found. Okay, return mid. Okay, else now we have the condition. Um, if ARR of mid is, let's say, less than search value, less than search value, Then left is equal to mid plus 1. Else right is equal to mid minus 1. Let's suppose we have this array. Okay, first of all, whatever the array we are getting, the first step is we'll do the sorting of that array. Okay. Um, just a minute. Screen sharing has been stopped. Give me a second.
So,
Visible now?
Screen share, yeah, now it is.
Yes. Yes. So here what we are doing is, again, let me explain. So let's suppose we are searching 59 over here, or let's say I'm implementing searching 21 over here. Okay. So what it will do is, first of all, at this step, at initial step, it will search for this. This is left position, so this is 0, and this is right position. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 11 elements are there. So the biggest value is 10. So right left value is 0 and right value is 10. So now it is checking 10. It is checking left is less than right. So yes, this condition is true. So mid value is checked 0 plus 10 divided by 2. So the value of mid is 5 now. Okay. And now what it will do is it will compare the element at fifth position. Okay. So fifth position is 0, 1, 2, 3, 4, 5. So at fifth, this element is there. This 21 will be compared with this value. Okay. So now this element is 21 is um, less than the this value. So what it will do, what this condition will become, this condition is already false because this is not equal. Then it will check. So ARR mid is less. So this condition is false because ARR mid is smaller than is greater than this 21. Okay. So now this part will be executed. So value of left will be as it is 0, and value of right will be mid minus 1. So mid is this right now, mid minus 1 is this. Okay, so this is mid minus 1. So now in the second part, this will again do the processing of over here. So again, now mid is sorry, high value, right value is this, and left value is this. Okay, so it will check left is smaller than right. So here this will be 0 plus, and right value is 0, 1, 2, 3, 4. Right? So this is 0 plus 4 divided by 2. So value at 2. So value at 2 is 0, 1, 2. This. Right? This is the mid value right now. So ARR of mid is equal to search value. So what is this? This is now equal, right? So it will return this 21, this mid position. This is 2. This clear? Is this clear?
Mhm. Looks okay.
Pramila, Priyanka,
yeah, yes, sir.
if you have even the smallest doubt, feel free to ask. I am ready to solve any kind of your doubt, but you should be clear with the concepts.
Sure. Why? Just one question. In the
Yes.
else condition, why we are not using like return?
In this else part you are asking, no?
Yeah, yeah.
Yeah, we are not using return because we two things. One thing, either we have to get the value whenever the values are matching. So here in mid part we are returning this. So when mid part is equal to search value, it will return that. But when this entire part is not working, means it will keep on searching, and after keep on searching, uh, it will find at some point, the point will be that uh, right value will be less than left value at some point, right? So at that point, this entire loop will be terminated. So this means that the element that we are willing to search is not found. So suppose, let's say I want to search 20 over here. Okay. So what will happen here in this part, now where this 21 got confirmed. So low is at 0, and now right is left is at 0, and right is still at 4. Okay, this 4 plus 1, this will be compared with this. So it since this is equal to the this 20, sorry, it is less than 20 is less than this. So again, this part will be executed, right? So now what will happen? Right value, the left value is still at 0, and right value will be this value index minus 1. So right value will be this. Okay, so this is 0 plus 1. 0 plus 1 divided by 2. So now this is 0.5. So now what will happen? Left is also 0, and right will also be 0. Understood? Understood? Left
Yeah.
is also 0 and also be 0.
Okay. So this both. mm, Okay, but this generally happens in only one scenario, like when left is less than right. Only in that case, right?
Yes.
Yeah, yeah.
Is less than left, it will be working. Either it is equal to 0, either left is equal to right, or left is greater than right. This loop will be terminated. So when left is here, right is here, okay, then mid will be again 0 only, right? This will then mid will be compared with this, and then it will then right will be coming at minus 1. So at this point of time, this entire loop will be terminated, and this minus 1 will be returned, which will indicate that the element has not found. Okay, understood? See, it is little tricky, but little only, not much. So you don't need to worry too much. Just you have to practice and understand the concept. Okay, so now I'll make an array, and I'll do searching. I'll do this searching part. Okay, so let's make my array is equal to, and I am making this array an dot array, and here I'm taking this I comma, and I am giving list over here. Okay, so first of all, um, let me take the random elements. So I'll take 21, 47, 89, 34, 57, 54, 77, 90, and 32, and then 56 I'm taking. Okay, so I have taken 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements I have taken. Now, what needs to be done is, first of all, sort the array. So how to sort the array? We saw it over here. First of all, we have to convert this array into the list, and then we'll convert back. We'll sort it and we'll convert back. Okay, so we'll convert this here, where, yes. So here, list of ARR is equal to two underscore list of my ARR. Okay, and then list underscore ARR dot sort, and then my ARR1 is equal to an dot array and I comma list underscore ARR. Okay, so now I'll print both, print my ARR and print my ARR1. So let's see, two dot list. Yes, okay, two dot list or two list. Oh, sorry, this is other way around. My ARR dot two underscore
Two list.
list dot two list. Okay. So you can see here, this is our original array, and now this is sorted array. Okay. Now I'll take the searching element. So print, search val is equal to integer input. I'll take in enter the element to be searched. Okay, and here it will take. Now what I'll do is I'll call this function bsearch. Bsearch, here I'll pass this my ARR1 comma search underscore val. Okay, and here result. Okay, now I'll check if result is equal to -1, then print element not found and else print element found at position. Here I'll take result +1. Okay, is this clear so far? Is this clear so far?
Yeah, yes.
Okay, so I'll execute this and then I'll execute this. So now element is created. Now I am searching, let's say 67 I am searching. So element not found. Why so? Okay, let me check this again. Even 89. 89 is found. See, it is telling that 89 is at ninth position. Wow. One element is found, another element is not found. Okay, so let's say I am searching 54. 54 is found at fifth position. Right? Let's say I am searching 88. Okay, so element not found. It is working fine. Let me search the 67 again. 67. 67 not found. How come? This is strange. All elements are getting searched. 21 at first. 21 at. Okay, 21 is also not found. Okay, let me check another. 43. 43 is found. Then 56 found at sixth position. Then 77 found at eighth position. 90 is found. Why 90 is not found? Why at some position it is telling that it is found, and for some other it is telling that it is not found.
Is the insertion order preserved? Means my question is
Sorry?
like, yeah, the order which in which we are storing, is it the values, is it preserved? Means, is it persistent or not? That might be the reason.
Persistent? I didn't get the meaning of persistent.
Means actually I'm telling based on Java. So what happens that it should be stored in a particular the left hand side should be either in a particular order. If for example set what does or we have done like two list. Okay, so here the two list, is it persistent or not? Means is the insertion order preserved or not? Therefore it might be the reason in which we are storing the value, in which we are storing. Is it and does it randomly means stores the values, or how is it?
No, no, this is stored not randomly. These are the continuous memory allocation. This is not stored in any random order. These are the continuous memory allocation.
Yeah, okay. Which we are doing like my ARR dot to list. Is it fine, right? In this line number 2 of 45.
Yes, yes.
Okay, then it's fine.
List error again. Let's say I am searching 60s. Find binary search file left is but is equal to left plus right divided by 2. Error met search value return met else if error met less than search value left is equal to met plus 1 else right is equal to met minus 1. This is also consistent. Why it is not working? Then um, it is giving array for one or two element. Why this element is not found? Okay, let me search it one by one. Uh, Let me debug it one by one, so it will make a clear picture. So let's see here. let's say okay, I'll just execute this portion now without calling. I'll use this directly. To search, let's 56. My error. Now, where is the error? Okay. It is stuck at fifth. Okay. First of all, okay, stop. It is first of all taking printing this mid at 4. So at first position, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9 divided by 2, it will be at 4. So fourth is at this. Okay. Okay. So fourth. Okay. No, fourth. 0, 1, 2, 3, 4. Fourth will be at this position. So now it is strange why it is giving just give me a minute, I'm getting a call.